a joint talk with Michal Malohlava and Richard Garris. And I don't think we have the slides up for this one, but after this, all the talks, I'll point you to where the slides are before the talk. All right? Thank you.
Okay, good afternoon. I hope you are enjoying H2O World so far. So this is more like demo session showing you how to deploy H2O on the top of Databricks Platform. So let me introduce Richard, who is from Databricks and who helped me with all this stuff, with the deployment of Databricks Platform and with running Sparkwater or H2O on the top of that. So Richard, can you tell me something about Spark and Databricks?
Sure. So Databricks is a cloud-based platform for running Spark. We started about 2 years ago out of the Berkeley AMP lab. With Databricks, what we try to do is try to make big data simple. So one of the things we heard from our customers that use Spark, either in Hadoop, on Mesos, is it's still hard to get Spark set up so that you can actually be productive as a data scientist. So we launched Databricks, which allows you to spin up and spin down clusters very quickly. It allows you to do interactive visualizations with notebooks. And we'll talk more about that as we go through the talk.
Okay, so let's go forward and
Yeah, so how many guys here use Spark today for your data ingestion analysis? Come on, that's more than that. All right. So Spark started in 2009, as many of you know. It's an open source distributed platform for doing analysis. So one of the things I want to talk about a little bit, so we have RDDs, data frames, and in Spark 1.6, we're introducing a new concept called data sets. So one of the things we heard from feedback from data frames is that it's a little too heavy, whereas RDDs were nice and lightweight. You could do a lot of different analyses with them. So we introduced data sets, which is a new paradigm for how you do analysis. So again, our platform components are Spark SQL, MLlib, streaming, GraphX, true multi-tenancy, so you can do a lot of different workloads all at once in the same Spark platform. We have a large and active community. Today we have over, what's the last count? Over 100 committers. And here at Databricks, we still contribute 3/4 of the code base to the Apache Spark project. And so we'll get to the demo, and we'll show a lot of this when we go to the demo. But our platform we have, Databricks, allows for integrated collaboration for doing data science. We have a notebook interface inspired by IPython notebooks and Zeppelin, but it's a specific notebook type, specifically for Spark. And we also have a self-service cluster manager to make it much easier for you guys to spin up clusters, schedule your jobs, and so forth. So I'm going to have Michal talk about H2O.
Okay, so there is probably like crucial question, like we are asking, okay, this is H2O World, so why we are speaking about Spark? So, you know, we know that Spark is really powerful for data managing and running large distributed jobs. So there is a like crucial question: can I run H2O on the top of the Spark? And the answer is yes. We can run on the top of the Spark. And the project which is implementing this, which is implementing like execution of H2O on the top of the Spark and also on the top of the Databricks platform, is called Sparkwater. And what is Sparkwater? It's really transparent integration of H2O to Spark ecosystem. It means that you can use any H2O algorithm with Spark data structures, and vice versa. So if you produce some table, H2O table in R, let's say, you have a table stored in the cluster, you can expose the table as regular Spark RDD or regular Spark data frame. And this really excels in the workflow when you have existing Spark pipeline of the processing pipeline, and you would like to call some advanced machine learning algorithm. So in this case, you can use Sparkwater. So how does it work with the Databricks platform?
So within Databricks, we take Spark and we make it available in the cloud. So one of the things that's changed over the last, even the last 5 years, is adoption of cloud in terms of AWS specifically, as well as Azure, IBM Software, and so forth. and it gives you true elastic compute. So no longer do you have to like wait for IT to spin up a cluster for you. You can actually just go to Amazon and request a cluster, and you're ready to go. So within Databricks, we make it very easy to do this. You can have your Spark clusters that are set up as EC2 machines, allow you to run Spark workloads. And then with integration with H2O, you can actually set up H2O as well in the same cluster. And Michal can talk about how that integration works.
Yeah. So the integration is quite straightforward. So we have running Spark cluster, which is sitting on Databricks Platform, and now we can create, it's called H2O context. So we follow the concepts of the Spark. So Spark introduced Spark context, SQL context. So we introduced H2O context, and H2O context represent a state of H2O cluster. So you can create H2O context and start it. And the start means that we will initialize H2O services on each node of the Spark cluster. And then if you have H2O services running, you can use all the power of H2O. And also we provide some utilities, how to publish data from H2O to the Spark and back.
Yep, absolutely. And just one other thing to add, so whether you're using H2O or Spark, you can use the programming language you're comfortable with. So if you're doing data science in R, Python, or Scala, you can still use the combination of these to do your data science workflows.
So let's play
with it, yeah.
So what do I need to run Databricks Platform?
So it's very simple. You need a laptop. It doesn't matter which type of OS you use. You can simply go online, sign up for a Databricks account. We have a 14-day free trial. You add your AWS account, and you're immediately able to do data science with big data sets, in the terabytes or petabyte scale. It's very easy to do. And then you can use H2O by installing the sparkling water jar.
So we have a small, cool idea how to show you how we interoperate with Databricks Platform. And the idea is called ham or spam. It's in fact spam detector filter. And one note, technical note, if you are interested in the details of this application, there are another 2 sessions which are describing how to build this application in more details. This will be only quick demo on the top of the Databricks platform. So there will be a simple spam detector, and the input of the spam detector is a raw text. In fact, raw text messages which are annotated with the spam or ham annotation. And it's just saying this message is the spam and this is regular message. And our goal is to train a model which will predict for a new incoming message if it is spam message or if it is regular message. That's our goal. And we also would like to show how to build this simple workflow on the top of Databricks platform. So the machine learning workflow includes several steps. So we need to load the data, then we need to perform some data munching of data. So we will parse the data, extract the text messages, we'll tokenize text messages, then we'll use TF-IDF model, which is inverse document frequency model, which in fact reflects what is the weight of the words inside the whole document. And this model gives us numeric representation for textual messages. So the input are text messages, but output of these TF-IDF models are numeric vectors. And that's perfect job for H2O. At this point, we'll employ H2O deep learning model or deep learning model builder, build H2O model, and as the last step, we'll create simple method how to use the model and predict or classify new incoming messages. So let's switch to the Databricks platform and play with it.
Yeah, so this is the Databricks platform. So one of the things you can do with Databricks is very quickly spin up clusters. So one of the things you can do is, say I want to create a cluster, say it's H2O world. Say I want to use Spark 1.5. I'm going to use on demand to spin it up very quickly. You can spin up a cluster and it takes only a few minutes. So one of the things we want to do in terms of data science is democratize it. So there's not as much work in order to actually spin up a cluster and get productive on Spark and also on H2O. So this is our spam detector. This is our notebook interface. So if you guys use, what do you guys use for data science? You guys use IPython? IPython, okay. Anyone use Zeppelin? Zeppelin, okay. How many people use like an IDE, RStudio, Eclipse, something like that? Okay, just kind of get an idea of what people generally use. So this is the notebook interface. So it gives you the ability to do things like you would with other notebooks. So you can do things like Markdown. You can document your data science workflow in the same place you actually write your code. And then you can do, what Scala really recommends is doing a REPL interface. So as you actually write code, you can see results right away. You can also do things like explore data with SQL. So many people will use SQL to do the initial data munging. So you can do that using Databricks and Spark, and you can actually feed that into a machine learning model like H2O. So you can do data munging in the same place you actually do your training and data science work. You can also do exploration of data sets. So you can look at distribution between ham and spam. So it's about 25% spam and 75% ham. You can also switch your plot around. So maybe you want to look at this as a bar chart. So it gives you kind of a quick and dirty way to do that. So Michal's going to talk to you a little bit more about some of the training and the tokenization steps that are required to build the model.
So what we did, we explore the data. So we know that like spam are some rare messages inside the data, and then we need to start building machine learning workflow. So first step is like more technical step, just define the representation of the message. So it's a text message and it has the annotation, which is the target of the training, and vector of numbers, which is representing a message. Then we have a lot of incoming textual messages, which are raw messages. So we have to preprocess them. How we'll preprocess them? We'll just take the message, we'll tokenize the message to the tokens based on the white spaces. Then we will get rid of the words which we don't need, and also the characters which are useless for us. And the output of this step is just RDD. This is still Spark API. This is the Spark data structure. So output of this step is the RDD, which contains the arrays or list of the tokens representing individual text messages. In the next step, we have to define this inverse document frequency model. So again, there is a Spark API, Spark library, which is quite handy, so we'll use it. We don't want to develop by ourselves, and we don't have it in H2O, so we'll use Spark. And it's really simple to use it. We'll just create simple hashing function, which will hash the words to larger space, and then use built-in inverse document frequency model of Spark to generate feature vectors for these messages. So at this point, we will have table of the vectors, which are numeric vectors, and each table, each row is annotated with ham or spam annotation. So that's perfect input for H2O. So in this point, I can switch from Spark API to H2O API and create H2O deep learning model. This is tricky point because for this point, I have to have the H2O Spark Inverter library. So what we did before, we created, I will go back to the notebook later, we imported Spark Inverter library directly from Maven. So which is a really cool feature. You just put here, it's called Maven coordinates of the current version of Sparking Water, and Spark will directly download all the jars which are important for this coordinate, and it will import all of them. So we already imported Sparking Water packages, and you can see there are a lot of H2O packages, so you can use them directly as well. So I will go back to the demo and continue with the deep learning model. So in this case, as I mentioned, we are building H2O model. So we create some input parameters, we specify training data and validation data to have some notion of the quality of the model. Then we set up the specific parameters for deep learning model, like the penalties and the hidden layers, and just simply run deep learning. At the end, the run will return deep learning model. So, and that's all. We have all the building steps ready. So right now, I have to initialize H2O context to put all the steps together. And you can see here in the presentation that we are starting H2O context, and it will give you, it will start H2O services on each node in the cluster, and it will give you the address of our UI interface. So I will quickly show it, and since I launched H2O, I can directly go and use also H2O Flow. So we can run on the Spark, you can use Spark Notebook, but if you need to do something with the Flow, you can directly use H2O Flow. So I will go back to the notebook and put all the application together. So I will just invoke individual steps which I define. I will read the data, tokenize them, build the models, and that's all. But what I can also do, if I build a model in H2O, I can explore the model. I can explore the quality of the model. I can look at the model metrics, which can tell me how the model is good in this context. So I can look at the model directly from the Spark or Scala API by typing DL model directly in the notebook, or I will just use model metrics to get the specific metric. For example, here we just get AUC metric for training data, which is quite good. It's one, but I'm more interested in the IOC metrics on validation data. Or I can go directly to the flow and explore these metrics in the flow. And this is exactly what you saw here before, and what you will see here in the next sessions, like interacting with different languages and with the flow, and do analysis and scoring and model building with H2O. I can even use all the features of the H2O. So I can look also on the generated POJO, which is representing the code of the model in plain Java. So I can, in fact, combine power of both platforms. So and finally, I can define the spam detector. So the spam detector is simple function. It takes models which I built as an input, and also incoming text message. Incoming text message is just message which I receive in my mailbox. And the spam detector will give you answer. This is the spam, this is ham. So I built several messages. So the first message, Michal, I received this message, and it says, Michal, there is a party tomorrow night in Mountain View. And it's H2O World Party, so everybody is invited here. So is it spam or ham? I don't know. So I run my analysis tool, which we built here, and it's saying, okay, it's good message, it's not spam. But then I received yesterday morning another message, we try to contact you, your reply and blah, blah, blah. So it seems like spam. Let's run it. And the spam detector which we define on the top of Sparkwater and Databricks Platform give us the answer, yes, it is spam. That's perfect. Okay, thank you for your attention.
So we have time for a number of questions. Got one up here. Navi, you want to?
So this is all folded up here.
A pipeline in Spark created and cached an RDD. Is there going to be data copying to H2O, or is H2O going to work directly on that RDD in memory in Spark's context?
Yeah, that's good. That's a good question. So there are like two situations. You have data in H2O, and you would like to expose them as RDD. In this case, we do just simple stuff, create a wrapper around our data structure, and expose as RDD or data frame API, and you can use it directly without any data duplication. On the other hand, if you go from RDD to H2O, you have to, we have to take data and transform them to our data structure to run our algorithms. This is a bit tricky, and we have to duplicate data. But what we will do in H2O, we will read the data from RDD, but we are in the stream will compress them. So we can see that we save a lot of space with respect to data stored in regular RDD. But of course, it depends on the type of data. So if you will have some string data, the compression will be one-to-one. But if you will have some numeric data, we are doing pretty good job in this sense.
Anyone else? Other questions?
Spark or Databricks has its own machine learning, ML something it's called, and forget what the something is. How would you compare using H2O versus the organic machine learning package in Spark?
So can I paraphrase your question? So you're asking the difference between MLlib and H2O, or MLlib, or just, excuse me, creating your own ML library and H2O?
I was asking MLlib versus H2O because from 10,000 feet they both work on, do machine learning on Spark. So how would you compare them?
Yeah, that's a good question. So, so MLlib has a number of algorithms, not all the same algorithms that H2O has in terms of deep learning. We did launch our first deep learning method, multi-layer perceptron, which came out in 1.5. But there's some differences in terms of the training and so forth. So with MLlib, every piece of code in MLlib is based on Spark. So if you were to design your own machine learning library with Spark, that's what MLlib is. So H2O is a little bit different in the fact that they've kind of developed machine learning from scratch. Michal can talk a little more about that. And so there's a little bit of differences in how this has been implemented. So you should evaluate both in terms of what software provides you the best algorithm and model that given your business problem you're trying to solve.
Yeah, so our point of view is that we are looking at collaboration of both machine learning libraries. So there are like missing pieces in H2O, machine learning, like text processing, let's say, and it's done already in Spark. So why we would duplicate the work? So we just use the Spark text processing or text word-to-vec vector. And vice versa, why Spark should duplicate the work which is already in H2O. So that's why like we can see like more like the collaborative approach, that you can combine both platforms together and produce the best possible model, best possible output with both platforms.
I have a question regarding the why should I use sparkling water inside Databricks or H2O inside Sparkwater?
So Databricks is a platform, and so it sits on AWS. So it gives you the advantages of being able to spin up and spin down clusters very quickly. You get the integrated notebook experience, so there's a lot of advantages there. So you can use SparkR on your own hardware using H2O, using sparkling water. It all depends on what you feel most comfortable with in terms of how you want to do your data science work. Does that answer your question?
Yeah, like if I'm using both on Databricks, what is the main advantage of using one or the other?
Yeah, so it gives you kind of an end-to-end flow. I mean, so when we talk to data scientists, one of their pain points is really being able to get access either to the cluster, to the data, to spin up the environments and so forth. Here you go on the web page, you sign up, and you have a complete workspace for doing data science work. To install H2O Flows UI as well as the Sparkling Water library, it's just point and click. So it gives you the advantage of day one being able to actually get to take your raw data and turning it into some kind of valuable insight. And so we really focus on that as kind of our value proposition for Databricks.
Anybody else?
So it sounds like Spark is very rich and has a lot of functionality and so on, and geared for big data. So what is really the benefit of using then H2O on top of Spark? I mean, you get additional algorithms, and what else?
So I would say additional algorithms and often the speed. So H2O itself is really optimized for machine learning or statistics or math computation. On the other hand, like Spark is designed as generic computation engine. So they have to be stable, they have to compute in a large environment, but we really focus, and also our data structure are tailored to math computation. Also, we are driven by the quality of the algorithms. So we are putting a lot of QA, a lot of quality effort to verify that our algorithms are correct. They are producing the right number, not only on the small data or medium-sized data, but also our guys are trying to prove that if you run our deep learning on big data, it will give you the expected results. So that's our main strong point of using H2O on the top of the Spark.
So if I can address this a little bit, within Python, you can find actually several solvers for the same general type of algorithm. And so you could ask the same question, well, why use this one versus that one? Most of us, when we're doing this data science, those results in these models are tied to money, right? We want the highest accuracy we can get. Of course, it's slightly more complicated than that. We want the most accuracy we can get in the time we have. And so really this comes down to, these are both options, out in the ecosystem. And the thing is for you to explore and see what works for you. What's giving you, the models that you need to get you the highest accuracy rate. And what's giving you it in the time frame you need. And there's differences in the implementations, and I'm sure for pretty much any of these algorithms that you're going to find in these ecosystems, there's a data set that will cater to that specific algorithm. And so which of these algorithms is going to perform best in your data set? It's hard to say. And so a lot of this is try it out, see what your results are, see what your experience is, because it's going to be sort of problem dependent. We got another question.
Spark uses LRU caching. Can you highlight about H2O and when Spark and H2O coexist? You briefly touched about the data copy and stuff, but was wondering how the utilization of memory happens and which takes up more memory.
Right. Yeah, so I wanted to kind of debunk a little bit of a myth. So a lot of people say that you only get the speedups from Spark if you cache, which is actually not true. So if you look at the benchmark from last year, the pterosaur that we won, we did that with no caching. We were 3 times faster than Hadoop with 0 caching. So the real benefit you get from Spark is really pipelining. So you can define all the transformations you want to do on your data up front, and then until you call either collect or some other action, it won't actually take effect until you've done that. So it allows you the ability to do transformations very, very quickly. So in terms of the caching questions, obviously, Michal is going to be better to answer caching in H2O and how that works.
Yeah, so as I said already, so what we are doing a lot of like technical tricks inside the platform. Compression is one. Compression of data per column is one of the tricks. Distribution of data around the cluster. Then if you fetch some data, we cache that locally on the node, so we avoid data transfers. Then we preserve the locality of the computation with data. So these like small, small tiny computation bits putting together, and really the goal is to avoid big data transfers around the cluster and do the best possible computation on the data. Inside the Spark, as I already mentioned, we have to collaborate with the Spark. So we can expose H2O frame, our data structure as data frame or RDD API, and vice versa. We can publish RDD and data frame as H2O frame, but there is this data transfer from Spark data structure to H2O data structures.
Oh, I think we've got one back here.
Hello. Yeah.
Hi.
So you guys have any stats that when you use H2O in raw mode and with Spark, what was the performance difference?
Can you repeat the question? I'm sorry.
So H2O with Spark and H2O standalone cluster. So do you have any statistics which performs better, H2O with Spark or?
So yes, I can answer that in two ways. I mean, data science is a workflow, as you all know. So it starts with your raw data set, which we saw here, which was just a message, just text, and goes all the way out through your training, and then through your evaluation, and then your actual prediction or scoring. So where Spark historically has always been is on the data munging side. So its ability to take these raw data inputs and clean it up and turn it into usable data that can be then fed into a machine learning training type model and then output as a predictive model. So you really need all pieces in that flow to be successful. So that's where we really shine, is really on that core data munging. And then H2O has specific methods in machine learning that you can use to actually do your training. So to answer your specific question on performance, as far as I know, there's not data munging in H2O. So you're going to see a lot of benefit in terms of how you do your transformations, whether it's using SQL, using R, using Python, using core Spark as the first step, and then subsequent steps you'll see performance gains in terms of using H2O's training methods. Do you want to add anything, Michal?
Yeah. So the Spark is very strong in this functional style of programming and that defining the transformation steps. We can do that from also from H2O. You can do that from the R package or from Python package. You can do that with a little bit more effort from Java or Scala. And in Spark, it's, I would say, nicer. And then, if you prepare the data, which you can pass to H2O, you just plug the H2O and build a model or do some transformation with the data, which is, let's say, easier in H2O. And it's really as I already mentioned several times, about the collaboration. What is the best tool which I can use at a given point of the computation? And what I learned at the company, at H2O, during the last 3 years, that really, this machine learning job is about the exploration about data and playing with the algorithms and observing and understanding the data.
I had one question. So I missed one part. So Databricks Cloud has its own UI, and you could load the jar you mentioned for H2O and execute the notebook there, right? Did you have an example that executes the notebook in Flow in some way that still talks to Databricks Cloud?
So we have, in fact, what I show here, this is running H2O on the top of Databricks Cloud. And what I was doing here, I was just looking, okay, what is the size of the cluster? So what you can see here, I hope I will do that like this, that there are some machines running, and I can type regular H2O commands like give me the model or predict something on the top of the model, and that's how it works. And you know that the big benefit of running of the flow is that if you have flow running, you can also use the REST API of the H2O. So that means that if you are more familiar with R or Python, you can just run your R session and connect to this Databricks platform from R, but from H2O R. Or you can just use also Spark R. Yeah.
Oh yeah. So in this case, you're just getting the model in.
Yes.
Okay.
Yeah.
Do you have a full example that we can download? Because
there is the example which we show here. It's in the H2O World 2015 repository, and you can download it and try to deploy it. I'm not sure if I'm able to share the notebook directly from the platform.
You can actually check it into GitHub. So maybe we'll do the actual notebook check in to GitHub, but we'll do that after the conference.
I read somewhere that for H2O, the memory should be almost like 4 or 5 times the data size. Is this still true?
So it depends, it depends on your input data. So we can see a lot of benefits from our compressions on numeric data, but of course, if you have like a lot of unique string or text, a lot of unique text data, then we will a little bit like have the same compression ratio as Spark. But on numeric data, we can do a lot of good job.
I had a situation where the RAM, the total amount of data size was more than the RAM, so I tried to load it on H2O and it couldn't load it, it just failed. Whereas I was able to run Spark using GLM. But is there any way sparkling water is going to help here?
In this case, it can help because the front of the pipeline will probably, you are using Spark data processing, so at this point it will help, and then during the transformation to RDD, we will keep memory utilization low, I would expect. So we can chat about it offline because I think we are already gone with the time.
So we have time for one more.
One more?
So there's a lot of configuration parameter in Spark, and through the sparkling or flow, is that something that's automated, or is it being exposed so that you can customize to deal with large data sets?
Well, so for Spark configuration or H2O configuration or both?
Spark configuration.
So with Databricks, we provide like tuned clusters that the team that wrote Apache Spark actually advocate for. And so the cluster should be well tuned. That said, you can change your configuration directly in the cluster configuration page. So if you create a cluster, you can actually say, I want to change my configuration. But it's more art than science, so it really depends on nature of your data, type of clusters, et cetera, to figure out what's the right configuration for your system.
And the same for sparkling water. So in fact, you can pass through Spark configuration options for sparkling water and also for H2O. So the same principle here apply.
Yeah, so you would do that with the context, is that right?
Oh, yeah. It will read the Spark properties and use them and tune like H2O services on the top of the Spark.
Okay, thank you.
Okay.
All right, so let's have a round of applause for our speakers.
Thank you.